Now, one of the things we want to be able to do is simplify expressions with trigonometric functions. And one of the problems is number 4 on the extra practice side. I believe it says cosine of x plus tangent of x times sine of x.
Number 4?
Yeah, isn't that number 4?
The sine is first.
On the extra practice?
No, you're on the
Other side.
Other side.
Other side. Cosine. Sine. Oh, you're right. Well, it doesn't matter. I'm sorry. I wrote this backwards, but remember that this multiplication works either way. Yes? They wrote it the other way. It doesn't matter. All right. What I want to do is simplify this expression. Now I have some bad news for you. I like these, and I actually enjoy doing these because I don't know from the very beginning whether what I try is going to work or not. For every other problem since the beginning of the year in this course, I can tell you, looking at the problem, I can already see where it's going. I know it's going to work, and I can see all the steps in my head before I ever start. It's boring as hell. It's kind of like going on the same trip over and over and over again. And then, of course, I have to do it 7 times. These, on the other hand, when I get a new one, I got to try something, and it might not work. It's a complete surprise to me what comes out, and you'll see why. Now, this one isn't because I've done it so many times. But most of the time, when you do a trig identity, it's a little disconcerting at first. You look at it and you go, well, I'm going to try something, and sometimes what you try works, and sometimes it doesn't. That's where the fun comes in. And it's a surprise at the end. Because I don't know what the answer is when I start out. That's why I like them. They're the only problems in the whole book that I can't tell you the answer immediately. So here's what we're going to do. I'm going to try something. Now remember, this won't always work. I'm going to put, instead of tangent of x, what is a tangent of x equal to? What was your first trig identity without looking? Don't look. What's a tangent equal to? Over? Sine over cosine. So what I can do is, instead of writing this, they wrote these backwards. I should have written the other way. Instead of tangent of x, I'm going to put in sine x over cosine x, because it's the same thing. Got it? All right, now watch this. I need to multiply this together, and to multiply fractions, don't you multiply the tops and the bottoms? Wouldn't that be nice if you could just add that way? Just add the top, add the bottom. It doesn't work. You have to have a common denominator. Well, for this one, I just need a 1 under there and multiply. So what do I get in the top of this thing?
Sine x squared.
Almost. Sine squared x, don't I? This is sine squared x over cosine x. Now I've still got a little problem here. I need to add some fractions, but I don't have a denominator over here. So what do?
You also
Put it over 1, but there's something else. Don't I need a common denominator? And
a squared.
no, I'm going to multiply by something so that this is the same as this. I'm going to multiply by cosine x, aren't I? Now this is like the easiest trig identity in the world, or the easiest simplification, because we only use those very first big 2 trig identities, right? Did you notice that I used the tangent as sine over cosine? Now look. What's this?
Cosine squared x.
Cosine squared x here. And this one? Sine squared x And I have a common denominator of cosine x. What is sine squared x plus cosine squared x?
1.
1. Yeah, remember sine squared x plus cosine squared x was 1? Oh. This is just 1 over cosine x. Do you remember what that thing's called? This is called your reciprocal functions. The reciprocal of cosine, I would have called it cosecant. You probably would have called it cosecant, but they called it secant, remember? This is secant x, the reciprocal of cosine, c over b. This is kind of complicated, isn't it? If I took an angle, and I took the cosine of that angle, and I took the tangent and the sine, and I multiplied them together and added it to the cosine, I'd get the exact same thing if I took the secant. This could also be a trig identity, and it is. This is what we call this. When I write it like this thing is equal to secant x. This thing is called a trig identity. All I did was simplify one side, though. Got it?